All right, so we're asked to solve these absolute value equations, right? So let's just jump in and do it. Immediately, when it looks like this, when it looks like x plus a or minus, it doesn't matter if it's plus or minus, equals some constant, then we just separate it, right? So make sure that you guys are writing this down in your notes. We just separate it into x plus a equals positive c, and then also x plus a equals negative c, right? We always do it that way. So I'm going to rewrite this as r minus 1 equals 5, and then also r minus 1 equals negative 5. And we just leave it like that, okay? And we solve them both, and we have two solutions. So then I'm going to add one here, just algebra, right? And so I get r is equal to 6. Same thing over here. I'm going to add one here, and I get r equals negative 4. Okay. Now, how do I double check this? Well, we could do it in Desmos, right? So if I say Desmos graphing calculator, and somebody tell me how to do it. I'm not going to pass out the calculators today because we don't necessarily need to. Absolute value of, instead of r, I'll say x minus 1, right? Close that off. And then we're just going to say y equals, what did it say? 5, right? So y equals 5. And where does it cross? Guess what? Negative 4. And we're only looking at the x values, right? So negative 4 and positive 6. So let me just get a little screenshot of this. And so if we put that in here somewhere, whoops. So what I'm really interested in is this right here, negative 4 and positive 6. Okay? So let's move on quickly to the next one. So over here, I'm going to say negative 5 minus 3n is equal to 35. Also, I'm going to say negative 5 minus 3n equals negative 35. Okay? Over here, I add 5 to both sides. I get negative 3n equals 40. Divide by negative 3. And I get n is equal to, and we could just leave it as negative 40 over 3, right? What's that, like 30? It's like 13.1 or 13 and 1/3 or something like that, 13.3 repeating. Same thing over here, going to add 5 to both sides. Slightly different though. I get negative 3n is equal to, what's that, negative 30? Yeah. Then I divide by negative 3. I see some people shaking their heads. And then we get n is equal to 10. How do I double check that? Go to Desmos. And so here's what we're doing here. In Desmos, we're going to graph the right-hand side, and then we're going to graph the left-hand side. So this becomes y equals 35. That's the right-hand side of the equal sign. And then this one was negative 5 minus 3n. We can't do n, though. We got to do x, right? And so y is equal to 35. So that means I'm way up here somewhere. So I'm going to just come in here, change my y value. What do you think we should change that to? Something greater than 35, right? So I'm just going to put 40. Oh, it's got to be a little bit more than that. I also got to zoom out of the x values, it looks like. So I'm going to say negative 20. Oh, I got a negative of a negative. You see how I made a positive? That's funny. And then I'll make this 20. There we go. Now I can see it a little better. All right. So we've got positive 10 and negative 13. So that works, right? Let me take a screenshot of that. So that's good to know. We're doing the math right. And we'll put that right here. I'm going to just make it small, though. So if we do this on the graphing calculator, that's what we're looking for, right? We're looking for to double check and make sure our math is right. So on your test, when you go to do the work, I still want to see the work, right? Because you guys might make a mistake on your work, or you might. What if you only do it on the calculator and you put the numbers in wrong? You know, that's not good. So I want to see your work. So that way, if I see your work and you made a simple math there, I can give you most of the credit for the work, right? But if you don't show your work, then it's kind of hard to justify. You just have a wrong answer. You just get the whole thing wrong. So that's why we want to see your work. On this one, before, it's not quite like x plus or minus a, right? The absolute value equals a constant. So what I'm going to do to get it there is divide by negative 8, divide by negative 8. These will cancel, and I get 10k minus 3. What's negative 24 divided by negative 8? Well, it's positive 3, right? A negative divided by a negative is positive 3. Now, from here, I separate it. 10k minus 3 equals 3, just like the regular one. And then I get 10k minus 3 equals negative 3. Add 3 to both sides on both of them, right? I'm left over here with 10k equals 6. Divide by 10, divide by 10. And if you reduce that fraction, 6 over 10 reduces down to what?
3 over 5.
3 over 5. Now, as a decimal, it's actually equal to 0.6, right? Anyways, over here, I'm left with 10k equals 0, right? And so divide by 10 anyways, and I get k equals 0. Graph the original equation, right? So I'm going to graph this, and I'm going to graph this. So I'm going to come in here and change this to negative 8 times 10k, but I got to replace the k with x. So I'm just going to say, was it negative 10k or just 10k? 10k, but I'll put x. Minus 3, thank you. Minus 3. And then over here, this was negative 24, right?
Yep.
See, I typed in 25 instead of 24. So then it looks like it crosses here. So I'm going to zoom in a little bit so we could see it better. And so where does it cross? At 0 and also at 0.6, right? Which is what we calculated. So we kind of know what we're doing, right? Oops, that's not good enough. I want to get the x values, right? So we'll throw this in here somewhere. Again, we found that it was 0.6 and 0. We're only interested in the x values. This one over here, not quite where it needs to be, so we're going to add 5 to both sides real quick. You basically want to get a number, right? We want like x plus a, absolute value of x plus a equals some number. Then we separate it. It's just easier that way. And so that's what we're going to do here. These 5s will cancel, and I'll get the absolute value of r plus 7 is equal to 11. Now we separate it. R plus 7 equals 11. R plus 7 equals negative 11. I'm going to subtract 7 from both sides. So I get r equals 4, and then r equals negative 18. How do I double check it? Calculator, right? So I come up here, and it's, but I got to change it. So it's going to be x, x plus 7, right? Minus 5, right? And then what was this? 6? Yeah. And then y equals 6. Can't see anything, so I'm going to zoom out. That's really, really zoom out, zoom out, zoom out. That's exactly what I said, right? 4 and negative 18. So the beauty of these calculators and the SAT, if Mr. Adams were to make a mistake, it would reveal itself, the mistake would, when I go to graph it on the graphing calculator, right? Where can I put that? Will I put it right there? Perfect, right? And so again, we've got r equals 18, we got our negative 18, and then we got r equals negative 18, right? Except we have x, right? That's the only difference. So we got negative 18, and then we had r equals